Section: Introduction. In this section, we will discuss the remarkable advancements in AI over the past few years, which have been largely driven by global efforts to scale up models and datasets. Large language models, LLMs, have grown significantly in size, from just 1 billion parameters 5 years ago to trillions of parameters today. The motivation behind this scaling is the expected performance boost that comes with training larger models, known as scaling laws. However, these laws were based on the assumption of a fixed data source, which has been challenged by the emergence of cutting-edge LLMs that offer new ways to interact with data. Our previous research on the Phi models demonstrated that by using LLM-based filtering of web data and generating synthetic data, we could achieve performance in smaller language models comparable to much larger ones. For instance, our Phi-2 model with 2.7 billion parameters matched the performance of models 25 times larger trained on conventional data. In this report, we introduce a new model, Phi-3 Mini, with 3.8 billion parameters, trained on enhanced versions of the datasets used for Phi-2. Despite its smaller size, Phi-3 Mini can be run locally on a modern phone and delivers quality comparable to larger models like Mixtral 8x7b and GPT-3.5. The Phi-3 Mini model is based on a transformer decoder architecture with a default context length of 4K. We also offer a long context version, Phi-3 Mini 128K, which extends the context length to 128K. To facilitate community collaboration, Phi-3 Mini shares a similar block structure with Llama 2 and uses the same tokenizer with a vocabulary size of 32,064. The model features 3,072 hidden dimensions, 32 heads, and 32 layers, trained on 3.3 trillion tokens. Additionally, the model is chat fine-tuned and can be quantized to 4 bits, occupying approximately 1.8 gigabytes of memory when deployed on devices like the iPhone 14. Our training methodology builds on previous works that emphasize high-quality training data to enhance the performance of small language models, diverging from traditional scaling approaches. By carefully curating web data and incorporating synthetic data, we aim to reach the performance levels of larger models like GPT-3.5 and Mixtral with significantly fewer parameters. We focus on optimizing the quality of data for small models, filtering web data to include relevant knowledge and enhance reasoning abilities. In summary, our approach aims to achieve optimal performance by calibrating the training data to suit the scale of the model, ensuring that it is closer to the data optimal regime. By comparing our method with existing models like Llama 2 and training larger models such as Phi-3 Medium, we continue to refine our data mixture to enhance model performance across various benchmarks. Section Summary. In this section, we discuss the significant advancements in AI achieved by scaling up models and datasets, particularly focusing on large language models, LLMs, which have grown from a billion to trillion parameters. By leveraging LLM-based filtering of web data and synthetic data, we developed the Phi-3 Mini model with 3.8B parameters, showcasing performance comparable to much larger models like Mixtral 8x7b and GPT-3.5, while being efficient enough to run locally on a modern phone. Section: Post-training. In this section, we underwent post-training by fine-tuning our models through supervised instruction and preference tuning with DPO. We focused on creating and organizing various instruction and preference data to enhance our model's chat capabilities, robustness, and safety. We then evaluated our Phi-3 Mini model on standard open-source benchmarks to assess its reasoning abilities, including common sense and logical reasoning. We compared its performance with other models like Phi-2, Mistral 7b v0.1, Mixtral 8x7b, Gemma 7b, Llama 3 Instruct-8b, and GPT-3.5. To ensure fair comparison, we used the same evaluation pipeline with few-shot prompts at temperature 0. Regarding safety, we developed Phi-3 Mini in line with Microsoft's responsible AI principles. We focused on safety alignment during post-training, red teaming, automated testing, and evaluations across various RI harm categories. By leveraging helpfulness and harmlessness preference datasets, along with in-house datasets, we addressed RAI harm categories during safety post-training. An independent red team at Microsoft provided feedback to refine the post-training dataset, leading to a significant reduction in harmful response rates. Despite the Phi-3 mini-model demonstrating strong language understanding and reasoning abilities comparable to larger models, it has limitations due to its size, particularly in storing extensive factual knowledge. This limitation is evident in tasks like trivia QA. However, we believe augmenting the model with a search engine can help overcome this weakness. Additionally, the model's language capacity is mainly limited to English, and exploring multilingual capabilities for small language models is a crucial next step. While we have made diligent efforts to address challenges such as factual inaccuracies, biases, inappropriate content generation, and safety issues through curated training data and post-training improvements, there are still significant challenges ahead that require further attention.